You lose your phone. You lose your car keys. You lose your mind. Looking for a matching sock. We accept these everyday losses because human memory is flawed and our attention is fragile. But what if I told you that the smartest, most heavily funded, and theoretically most disciplined organization on the planet, the United States military, lost the equivalent of the sun not once, not twice, but dozens of times? Right now, as you sit looking at your screen, there are approximately 50 nuclear warheads lying at the bottom of the world's oceans. Lost. Unrecoverable, ticking. The Pentagon even has a cute, sanitized term for this level of apocalyptic incompetence. They call it a broken arrow. It sounds like an action movie. It's actually a classification for an unexpected event involving nuclear weapons that result in the accidental launching, firing, detonating, theft, or loss of the weapon. You probably think the military has total control over its arsenal. You think there are strict protocols, dual key systems, and fail-safes. But history is not a Hollywood script where the good guys disarm the bomb at 001. History is a series of bureaucratic errors, exhausted humans, and sheer dumb luck. Today, we are going to dive into the absolute absurdity of the Cold War. We will see how a single, flimsy 24-volt switch saved millions of American lives, how radioactive plutonium ended up fertilizing Spanish tomato fields, and why the real doomsday threat isn't falling from the sky anymore. It's rusting quietly at the bottom of the ocean, waiting for the salt to do its job. We'll uncover why the brightest engineers on the planet built perfect machines, only to hand them over to sleep-deprived 22-year-olds. Let's go back to February 5th, 1958. A B-47 Stratojet bomber is flying a simulated combat mission off the coast of Georgia. In its belly sits a Mark 15 thermonuclear bomb. This isn't a firecracker. It's a 7,600-pound cylinder of absolute devastation. At 36,000 feet, an F-86 fighter jet, also part of the simulation, didn't see the bomber on its radar. The fighter jet slams into the B-47. The bomber is crippled, plummeting toward the earth. Major Howard Richardson, the pilot of the B-47, has a choice. Try to land a broken plane with 3.5 tons of high explosives and enriched uranium in the back, risking a detonation on the runway, or drop the bomb into the ocean to save his crew. He chooses the ocean. He jettisons the Mark 15 into the shallow waters of Wassaw Sound, right off the coast of Tybee Island, Georgia. Richardson lands safely. The military rushes to the scene. They drag the ocean floor. They bring in divers. They search for weeks, then months. They never found it. To this day, a thermonuclear weapon lies buried under a few feet of silt right next to a popular tourist beach. The military eventually released a statement saying the weapon didn't have its plutonium capsule installed, making a nuclear explosion impossible. But letters from the Assistant Secretary of Defense later contradicted this, suggesting the core was indeed present. Regardless, it's there, waiting. But how did we even get here? Why were military aircraft flying over civilian populations with live nuclear weapons in the first place? To understand this, you have to understand the absolute paranoia of the 1960s. The United States and the Soviet Union were locked in a staring contest with fingers on the trigger. The logic of the Strategic Air Command, led by generals who believed war was inevitable, was simple. If the Soviets launch a surprise attack, they will destroy our bombers on the ground. Therefore, our bombers must never be on the ground. Enter Operation Chrome Dome. The idea was to keep a continuous 24/7 airborne alert. B-52 bombers, loaded with thermonuclear weapons, were constantly flying routes near the Soviet border, over the Arctic, over the Mediterranean, over America. At any given moment, there were dozens of nuclear weapons flying above the clouds. They told the public it was safe. They touted the concept of fail-safe. Let's step back and look at how a nuclear weapon actually works. It is not a barrel of gunpowder that goes off if you drop a match in it. A modern thermonuclear bomb is an incredibly complex, highly synchronized clockwork mechanism. To create a nuclear yield, conventional high explosives arranged in lenses around a plutonium core must detonate at exactly the same microsecond. Think of it like trying to squeeze a slice of deep dish pizza perfectly from all sides at the exact same time. If you push too hard on one side, the cheese shoots out the other. If the explosives in a nuclear bomb don't detonate with perfect symmetry, the plutonium core is blown apart without triggering a chain reaction. You just get a dirty bomb, not a nuclear blast. Because the physics required such immense precision, engineers convinced themselves and the generals that an accidental nuclear detonation was physically impossible. The machines were perfect, but they forgot one crucial variable. Machines don't fly planes. Humans do. And humans are exhausted, stressed, and prone to catastrophic mistakes. January the 24th, 1961, Goldsboro, North Carolina. A B 52 bomber is flying a routine Chrome Dome mission. A fuel leak develops in the right wing. Within minutes, the aircraft loses control and literally breaks apart in the sky. Two Mark 39 thermonuclear bombs, each with a yield of 3.8 megaton, that's 260 times more powerful than the bomb dropped on Hiroshima, fall from the disintegrating plane. One of the bombs plummets into a muddy field and buries itself so deep the military eventually gives up trying to recover the core. They just bought the land and put a fence around it, but the second bomb is the one that should keep you awake at night. As it fell, its parachute deployed. The bomb's internal mechanisms, feeling the parachute pull, assumed it had been intentionally dropped over enemy territory. It began its arming sequence. There were four safety mechanisms designed to prevent an accidental detonation. The arming wires were pulled. Safety 1 failed. The pulse generator engaged. Safety 2 failed. The explosive actuators fired. Safety 3 failed. The bomb hit the ground. The firing signal was sent to the conventional explosives surrounding the core. The only thing that stopped North Carolina from being turned into a glass parking lot was a single, cheap 24-volt toggle switch that happened to stay in the underscore, quote, underscore 2, underscore position. One switch. That wasn't brilliant engineering. That wasn't a robust failsafe. That was blind, terrifying luck. You'd think the military would stop flying nukes over people's heads after that. They didn't. Fast forward to January 17th, 1966. Palomares, Spain. Another B-52. Another Chrome Dome mission. This time, the bomber is trying to refuel midair from a KC-135 tanker. The bomber approaches too fast, colliding with the tanker. A massive fireball erupts in the sky. Both planes are destroyed. 4 hydrogen bombs fall toward the small farming village of Palomares. 3 hit the land. 1 lands in the Mediterranean Sea. 2 of the bombs that hit the ground undergo conventional explosive detonation. The pizza is squeezed unevenly. There is no nuclear blast, but the conventional explosion pulverizes the plutonium cores, scattering highly radioactive dust across the village's tomato fields. The U.S. military had to send in thousands of men in hazmat suits to scrape up 1,400 tons of radioactive Spanish dirt, put it in barrels, and ship it to a nuclear waste facility in South Carolina. But what about the 4th bomb? It took 80 days, a massive naval armada, and experimental deep-sea submersibles to finally locate and drag that weapon out of the ocean. The incident was an international humiliation. Still, Chrome Dome continued until the ice broke. January the 21st, 1968. Thule Air Base, Greenland. A crew member stuffs a few foam cushions into a heating vent to keep warm. The foam catches fire. The cabin fills with thick, blinding smoke. The crew bails out. The B-52, carrying 4 hydrogen bombs, crashes directly into the sea ice of North Star Bay. The impact and conventional explosion shatter the bombs. Plutonium is scattered across the pristine, freezing environment. The cleanup is a nightmare of radioactive ice and secret political negotiations with Denmark. Finally, the illusion shatters. The Pentagon realizes that the fail-safe is a myth. Keeping nuclear weapons airborne 24/7 is a statistical guarantee of eventual disaster. Operation Chrome Dome is officially canceled. We stopped dropping bombs from the sky. Problem solved, right? No, we just changed the delivery method. And in doing so, we shifted the threat from a spectacular, immediate explosion to a slow, silent poison. We shifted our focus to the oceans. During the Cold War, the ultimate deterrent wasn't a bomber. It was a nuclear submarine, silent, invisible, capable of hiding under the ice caps or off the coast of an enemy city, carrying enough firepower to end modern civilization. But submarines sink. In May 1968, the USS Scorpion, an American nuclear attack submarine, mysteriously sank in the Atlantic Ocean. It took 99 men to the bottom. It also took 2 nuclear torpedoes. In October 1986, the Soviet submarine K-219 suffered an explosion in a missile tube while patrolling the Sargasso Sea. After a desperate struggle by the crew, the sub went down, taking 34 nuclear warheads with it into the abyss. And these are just the ones we talk about. Dozens of submarines, both American and Soviet, lie on the ocean floor, packed with nuclear reactors and armed warheads. This is where the antagonist of our story changes. The enemy is no longer a tired pilot or a faulty wire. The enemy is time and physics. The ocean is not a passive environment. It is a highly aggressive, electrically conductive soup. Salt water facilitates galvanic corrosion. When you put complex metals, titanium, steel, aluminum into salt water, they act like a battery. They begin to eat each other. The casings of these warheads were designed to withstand the shock of a missile launch and the heat of atmospheric reentry. They were not designed to sit in highly pressurized, corrosive salt water for 50 years. The titanium housings are rotting, the containment vessels are breaching, and inside those vessels are the plutonium cores. Plutonium-239 has a half-life of 24,100 years. As the salt water breaches the casings, it reacts with the radioactive materials. We are no longer afraid of a sudden, blinding flash of light and a mushroom cloud. We are facing a slow-motion, invisible radiation tsunami on a microscopic level. These lost bombs are time capsules of toxicity. If the cores corrode and the plutonium leaks into the deep ocean currents, it enters the food chain. Plankton absorbs it, small fish eat the plankton, big fish eat the small fish, and eventually it reaches us. It's a localized environmental catastrophe waiting to happen, ticking away in the dark. So, the logical question is, why don't we just go get them? We have ROVs. We have deep sea technology. We found the Titanic. Surely we can find a missile. But the reality of the deep ocean is brutal. Many of these weapons lie at depths of 3,000 to 5,000 meters. At that depth, the pressure is crushing, literally hundreds of times greater than at the surface. Operating heavy machinery to delicately extract a decaying, structurally compromised nuclear weapon from the mud is not just difficult, it borders on suicidal. If you try to lift a rusted warhead and the casing cracks, you instantly release the contamination you were trying to prevent. The military has run the calculations. The brutal, cynical math of the Pentagon dictates that it is statistically safer to leave these apocalyptic devices rotting in the dark than to attempt a rescue. We are hostages to our own past. Humanity likes to view itself as the master of the universe. We split the atom. We harness the power of the stars. But looking at the legacy of the broken arrows, we don't look like masters. We look like a careless teenager who was handed a live hand grenade without the pin, panicked, and tossed it under the bed, hoping it wouldn't go off. Those 50 nuclear bombs resting on the ocean floor are not just military statistics. They are physical monuments to human hubris. They are the ultimate proof of our belief that we could tame physics, control chaos, and manage the unmanageable. We didn't tame anything. We just scattered our deadliest trash in the places we couldn't see, leaving a lethal legacy that will patiently outlive the empires that built it.